Okay, this is called Decoding the Earth. I'm Bill Pagano, and here's my credentials. Okay, the 4 PowerPoint presentations that I did before are over 10 hours combined, and this is what they're called. And like I said, this is sort of a trailer to that to get your interest so you can watch these other ones. If you really want proof, detailed proof, you see these 4. Okay, this tectonic model, as I call it, this is very important. It's structured, ordered, interrelated, and consistent. That's really what anybody's looking for in a model. So this is absolutely true. All right. It explains geologic mysteries, and some of them in great detail. Okay, and other ones there's this tremendous insight into, and it should be examined further. But I guarantee I'm onto something here, and a bunch of these are explained step by step, very, very, very much in detail. Okay, this model explains all important geologic events. The complete geochronology of the Earth is determined. Basically, every step of the history is shown, determined from the model. This model agrees with aspects of the current model. If not, can explain how the current model came to be. So that's a good sign. In other words, a lot of times maybe what they say about something, I can explain it better, and I can see why they thought something. There's this, in a sense, agreement. This tectonic model is verified, guided, and refined by fractals and geologic structures found on Google Earth every step of the way. This model is verified, guided, and refined by published geologic literature every step of the way. Okay, the basic framework of this tectonic model involves geologic structures. Geologic structures verify dynamics and tectonic conditions. So they can be present-day structures, true geologic structures, and they represent an energy. They're showing directions of movement and directions of energy and things that are actually going on. Geologic structures could also be fractals of Rodinia, because Rodinia in reality is a geologic structure. So you're seeing fractals of geologic structures when you see these things that look like Rodinia, which are all over the place, all over the world. And you could also see subdivisions of Rodinia, which are the 7 original continents or land masses. Okay, and now there's 6. One of them has went into the what is now the Mariana Trench, and I talk about that. So another element of the framework of this model are fractals. What are they? Well, they're very bizarre, and I talk about what they are in very, very good detail in Part 3 PowerPoint presentation. But the relationship to Rodinia is that a lot of these fractals are of Rodinia or Rodinia's subdivisions. Sometimes there are other things that are fractals, such as Boudins and things like that, but very often they're Rodinia or Rodinia subdivided as the original continents on Earth. And just keep in mind, all lines drawn on Google Earth show signatures and can be verified. So just check out anything and everything that I did. Some things are going to be easier to see than others, but I guarantee you can verify what I did is correct, because there's also a signature involved, and that's something that you just can't fake. So you'll see signatures involved in every aspect of what I have put in colors and everything on Google Earth. Okay, so here's an example of time sequence of fractals, and there's some structures here that are consistent with the fractals. For example, these n-echelon structures here on the lower right that I'm circling, they're shown in red. So they're really interestingly enough agreeing with, so to speak, with the fractals. This happens very often. And the fractals, again, show these distinct signatures and everything. Okay, here's another example of a time sequence. You can see labeled 1, 2, 3, and 4. All the lines are critical. They mean something, all interrelated on one given time sequence and interrelated between each other. Okay, here's another high energy event of fractals, and there's these structures here that I'm circling, and echelon structures again, that are agreeing with the whole dynamic of the fractals. Okay, here's a fractal or system of fractals, all interrelated, and they show like a progression here. Sometimes you see different phases for a fractal, and what's going on is all interrelated and can be explained as I do in the presentation. Okay, here we got there's a whole system of fractals and geologic structures that are interrelated. They all mean something. You have these compression things going on here. These are structures associated with tension, and it looks like they're getting pulled along a pathway. You have this blue structure that indicates a directional movement. You have another one here. So it's all interrelated. This is a fractal that mimics geologic literature, what they find, and there's some really cool stuff because different geologic events are shown in the fractal, the way it behaves, the way it deforms and everything. It even shows like a piece here that rolled over. I'm circling here. This thing in white actually is like a piece of land that rolled over. Very cool stuff. Okay, some of the specifics I get into on the PowerPoint presentations are the Thea impact, these geologic events. I'm saying it's about 900 million years ago. Now, Rodinia itself, which is a couple of billion years old, and it came from another planet, came from somewhere else, because it's a series of structures. It lands on the inner Earth at that time and initiates the equatorial spin axis. And you'll see on the fractals that this is shown. Okay, and the formation of the stabilizing locking mechanisms afterward. Okay, and the role of one of the subdivisions of Rodinia called the Southeast Asia Refold in maintaining equilibrium about the equatorial spin axis. So in a sense, this is the beginning of the mechanism of plate tectonics, of tectonics really. Okay, so fractals of the Thea impact are shown here, and how Rodinia stabilizes through the formation of a locking mechanism on each side, each pole, North Pole, South Pole, initiation of the equatorial spin axis based on this impact. So the sequence is shown here, 1, 2, 3, and 4, and you can see the subdivisions, which are the original land masses or continents. Some of those structures, the way they look, are still present today. If you look at Antarctica, for example, which is over here where I'm circling, still maintains that same look today. Okay, so we got absolutely whacked by this Canadian asteroid impact. That was about 800 to 750 million years ago. What that did is it caused, initiated the breakup of Rodinia, which had just stabilized with the locking mechanisms as I discussed, and it initiated tectonics on Earth, because what's going on is there's this chain of subdivided refold structures. I explain more in the presentations, but basically everything's disrupted now, and there's this severe rotation and oscillation of the chain about the equatorial spin axis. So the movement is lateral and longitudinal along it, and this one of the subdivided refold structures, the Southeast Asia Refold, I call it. It's very critical in maintaining equilibrium of this chain. It actually pulls things back in line along the equatorial spin axis. It pulls the adjacent refold structure back and everything. So equilibrium is maintained. And this action, this attempt at maintaining equilibrium, is basically the driving mechanism of early tectonics. Okay, these are fractals of the asteroid impact. I found like 7 of them. They go in order from left to right as if you're reading a book. Okay, really cool stuff. This is the disrupted chain structure after the asteroid impact, shown right here. Hit North America and Canada. After it hit, the chain was disrupted, and you've seen this before. There's these an echelon structures here. Everything's in agreement and related. This is the Southeast Asia refold right here on the top that I'm putting a check at. So that's the thing that kind of maintained equilibrium. It actually brought back this, what I call the Russia refold here. I'm putting a check on. Kept everything in line for that equatorial spin axis, which is shown in blue. You can see it's bent and disrupted there. Okay, this is a fractal of the chain structure that is now pulled back by the Southeast Asia refold, which is, I'm putting a check on right here. It pulled this Russia refold back this way, putting the arrow there. Equatorial spin axis is in green, so it's brought it back. It's trying to stabilize everything. And this is, in fact, the mechanism of early tectonics, this effort to maintain equilibrium about the equatorial spin axis. Okay, for the early tectonics regime, there's some interesting observations that I discuss in greater detail in the presentations. More interesting, obvious one is this time warp we're living in. That's based on the behavior of the chain of refolds about the equatorial spin axis that I discussed. There's sort of a train dynamic and everything, and these oscillations. Everything looks like it's very quick, but it's over millions of years. And it also appears that there's Earth expansion, despite, it's very controversial, but it does appear that way, that the Earth expanded since Rodinia first landed on the inner Earth. Okay, this is the train dynamic that I discussed. It looks like something that happened very quick, but it's over millions of years. In this fractal, it's closer to, well, the impact was like 800 to 750 million years ago, and that's up in this direction. Fractal itself is probably closer to 670 million years ago, based on geologic literature with rifting and all that's shown. But it's about 550 million years ago at this end here, so time travels this way to the west, really, because it's spinning to the east. You can see the green equatorial spin axis. There's an arrow that I'm circling. It's going to the east. There's this, in order to maintain equilibrium, there's these oscillations that it has to go through, so to speak, and it's kept in line by that Southeast Asia refold, which is shown at the top here that I'm highlighting. So anyway, the oscillations are going to the South Pole, which is where I'm checking here, to the right, to the North Pole, to the left, and also longitudinally along that green equatorial spin axis. You see compression and tension cycles. There's a compression cycle here. The tension cycles at the top because that's where the impact was. And so after you get like compression here, you got tension again, and then you got compression again down there. So there's these cycles, and things are, again, moving laterally and longitudinally. Geologic literature describes the breakup of and formation of these supercontinents at the time. So that's what's the reason for this, is this effort to maintain equilibrium about the equatorial spin axis. Okay, now there's something called modern tectonics, which is different from that chain sort of tectonics that was discussed previously. Now the chain was derailed, and the 7 individual refolds, the subdivisions of Rodinia, are now independent, and there's details that describe what's going on with these independent structures. And what's basically the dynamic is there's now rotation and directed suction to the inner core. That's what dominates the movement of the now independent structures, land masses, 7 of them. Okay, the driving mechanism of modern tectonics is basically that rotation and directed suction. You'll see that in the next several slides. And something to think about, the Cambrian explosion of life that began about 550 million years ago, just after this train derailment. Is this a coincidence or what? I'm not sure. This is the North America refold showing a lot of rotation. There's an asteroid impact fractal right there. Okay, so now there's a lot of rotation of the system of refolds, as you see in the black line here that I'm circling the arrow for. You can see it going around a circle and everything. And there's this directed suction here with these arms developing for these 7 refolds. Couple up and get these arms. There's 1, there's 2, and there's 3. Okay, here's my model of Pangaea, which I arrived at independently of the geologic literature model that I'm circling now on the left. They're actually very, very similar, and what happens is there's all these land bridges and superficial land masses that connect up all the holes and things like that, like the oceans here. There's a land mass here. So things actually start to look even more similar, like a C shape is how it's described in geologic literature. So I arrived at it independently of the geologic literature, and they agree. Okay, so under the modern tectonic regime of rotation and directed suction, one of the 7 land masses I call continent A. It's a refold structure, and its outline can be seen on Google Earth, and it's shown in red here in the middle where I'm circling everything here. So that shown in red is this continent A. It actually got pulled into what made the Mariana Trench, where the Mariana Trench is today. It formed the shape of it. As you can see, there's this arc-like shape that was formed by continent A going in there. And there's some evidence that that movement did occur because there's a structure over here where I'm circling, and it's shown in detail on the upper right here. Okay. Okay, I'm going to show a very brief geochronology with 4 drawings that I did and 7 fractals that show it. Okay. Okay, so you see this tectonic regime now with rotation. It's color-coded. Like, for example, the what I'm circling now is this continent A. You can see the purple path it took, and you can see this merry-go-round of rotation of the system. You can see directed suction. There's a little arm forming here where I'm circling. And in a sense, this is suction 2. It's the system trying to protect itself, sort of stabilize the whole system so it doesn't get pulled into the center of the Earth. So there's a lot to explain there, but here's more suction here. This is was suction before. It's this arm, and now it's gotten flattened out from the direction of movement. So it's the top of it where I'm highlighting is now flat, but it's all has to do with the dynamic that's going on here. Okay, in this slide, you don't see the counterclockwise lines showing the direction of the individual refold movements in a counterclockwise direction. You don't see that because what's going on here is there's this crushing now here, this compression. So this arm has gone down this way, at least in this area, it has gone in that direction, and then what that means is the Southeast Asia refold in green has gone this way. So that's a stabilizing motion for that rotation, that counterclockwise rotation of the system. So right now everything's a little quieter. Okay, this is like 55 million years ago or so. Okay, so the merry-go-round system is back, where you can see the movement with the red arrows and all. Reason for that is because this Africa refold went in this direction, which is like counterclockwise, to sort of stabilize the system, in particular to crush the, to stabilize that orange Russia refold. And you notice there's crushing in here, the compression. So by that movement, the Southeast Asia refold now goes clockwise and exposes and breaks the brittle upper crust so that there's some exposure to the inner Earth, and that's where things get attracted more. In particular, this what became India here, and continent A, which ended up in the Mariana Trench, as shown in the arrow. So if you look carefully, it also kind of reminds you of like a mud crack or whatever, where things are in the triple junction, sort of. See that? Okay, that means tension or expansion. Okay, so this is today, and this is just showing the area of the what I call the suture zone, where there's broken upper crust and the suture of the Southeast Asia arm, which sutures down to the inner Earth, which I never explained, but that's driving this whole system basically. So that's causing like this system is doing like a balancing act here. See with this Russia refold here, and which is C-shaped and all. And the arm over here of Africa, a little arm got crushed that I was discussing on the previous slide, but it looks like a balancing act between the arm of Africa here, where I'm circling, Russia refold here, and the little arm of Africa over there. So it's a pretty precarious situation today. Okay, these next bunch of slides are basically showing the North America refold, which in here is shown in yellow, and it's gonna be a lot of Russia refold too. There's this whole interactive play going on. Russia refold here is shown in blue and in red, just different phases. So again, the theme is rotation and directed suction and all that. At least as a system, everything's eventually going to get directed into that suction zone that I described really as a suture zone. This is an absolutely beautiful fractal of Pangaea breaking up. It's about 110, 105 million years ago. You can see the Russia refold falling off the back of North America here, which is, here's North America. Okay, going in time order, Yellow fractal is North America. That's when the land that now became what's near Alaska broke off of what is now New Brunswick. This is this area here where I'm circling. Broke under tension. And you can see South America refold in red, by the way, also. Okay, just a slightly later phase. This is the area that became, where I'm circling, that became Alaska area. This is New Brunswick, Canada area, broke off in tension. The leg kind of rebounded up a little bit here where I'm showing the arrow. Everything's interrelated from one phase to the next. Here's another fractal of North America. You can see some of the strain developing, probably rubbing up against the Russia refold here. This is Alaska area right here. Okay, here's a fractal of North America, South America, and Central America. Okay, looks like the arm here, which was building some stress adjacent to what was probably Russia refold located over here or whatever. Looks like it snapped, so you can see that it's got a different appearance than the previous one, and now it's actually, because of this counterclockwise rotation, it's actually building a little bit of compression in here. Okay, moving right along, there's this further counterclockwise rotation is shown here. It looks like that arm has advanced this way and relieved some of that strain built up here. It's less pronounced. And there's even a structure developing outlined in red here called an SC structure that shows a shearing direction, which is counterclockwise. Okay, so again, the structures verify these fractals too. And this could be reality too. There could be an SC structure in reality right now in North America, in that approximate area is shown here. Okay, so the next several slides are Earth today. You're looking on Google Earth and you can verify all the lines that I show. And what's important is that Earth today is a function of what happened in the past, and all those things that happened in the past are verified in the fractals and in the geologic structures, as everything is interrelated, as I'm explaining and as you can see. Okay, this is the North America refold. You can see it flipped over on its back about the asteroid impact area, which is here where I'm highlighting. And there's this pendulum-like rotation in Hudson Bay. You can see the movement there. This is the Great Lakes region. You can see the rotation about a pivot point here that I am circling now on the left side. See that pivot point, everything rotates about that. These are structures and fractals in North America that just verify that there's that rotation about the asteroid impact center in Hudson Bay. You can see all that working together. Blue here, SC structure. These are Boudins in yellow. That's a tension zone on the left side, and the compression zone is at the bottom and the right, which is associated with these red folded lines here. And there's a discrete path that the Boudins are actually working their way into the compression zone along this discrete path here, which I'm circling. Okay, like I discussed, there was this, due to tension, this between New Brunswick, Canada here, and what became Alaska region right now. There's the land just snapped off there in tension, and you can see like the structure in red. It sort of indicates this like a rubber band action that's snapping. All right, and then it kind of builds up in some slack in certain zones. Okay, so what I just said on the previous slide is verified by a structure here, indicating a direction of movement. And there's also verification by a structure right here, same type of structure. Okay, so everything's about rotation. You can see this in blue, there's rotation there. And in the arrows, the red arrows, it shows rotational directions, and they're associated with continental drift, such as right here, where Nova Scotia drifted off what was once New England area. Here's rotation again, Central America formed by counterclockwise rotation and flipping around of these what's called Boudins. They actually formed the islands, or are associated with the islands in Central America. And there's this whole bulldozing effect, which the lines are shown in yellow, and there's like a superposition of the way that these islands came across the Caribbean. This is the South America refold, and you see a Boudin path, which is on the outside fibers where I'm circling now. It has migrated from that to the yellow. So there's this sort of a, see what I have here circled now in the blue, there's this uncoiling kind of thing going on. And of course, rotation is counterclockwise. Okay, this is Europe and Asia. It shows like a major suction zone, sort of like a formation of a new supercontinent. And the fractals here, it's hard to see, but they mimic what's going on with this pulling into one zone. Okay, this is another view of that suture zone. This is the Southeast Asia refold here, and it's had a history of mostly clockwise rotation here, but there was some recent counterclockwise rotation, as you can see from the flattening and the movement of the little sections here. This is Africa, and you can see that little arm of it got crushed by the Russia refold above. Okay, some of the detail there, just checking out one angle. We'll see another one next. Okay, this is a more detailed angle here, and just to note there's some boudins here which indicate tension zone, and they are collecting because of counterclockwise rotation. Once again, everything's about rotation. Okay, this is a view of the Pacific, and like I said, this continent A got pulled into the Mariana Trench. You can see the outline of all these things. If you look carefully, you can see these things. You can verify everything I put in here. Okay, this is a view of basically the land masses in the Indian Ocean and Pacific Ocean, and again, that outline of continent A that you can see if you look carefully. All these arrows show the direction of movement of the land masses. Okay, part one was the tectonic history or geochronology of the Earth from beginning to end. Part two is other supporting evidence of validity of the model, just demonstrating the model is very good and consistent. The fractals are consistent. Great Lakes rotational signature mimics model tectonics, something very specific that gets into more detail on the main presentations. Fractals mimic model tectonics, of course, in general. Geologic mysteries are solved, sometimes very precisely, by model tectonics and conditions. Gravity and magnetic anomalies are explained. This is something that the model has to be good to really show why the anomalies are there specifically, and explains the reasons. So fractals reveal faults, fault systems, and fault interrelationships. That'll be part three. That's just another strong point of the model. Very strong point. Okay, these are two fractals of the inner Earth, shown outlined in yellow on the left and shown outlined in blue on the right. There's this consistency in this model for these fractals and other fractals too. Okay, these are fractals of the Great Lakes, and they are mimicking tectonics. And I get into greater detail, of course, in the presentation, but you can see that this one on the left becomes the one on the right at a later time. You're just shifting that pivot point in a clockwise direction. Okay, so fractals mimic tectonics. You can see there's a tectonic thing going on here with Google Earth, and you can see it's mimicked here by this guy in the middle. This is the Russia refold, the fractal of it basically, and all the forces are coming in. Everything's trying to get inside there, sort of like it is here on the left. Okay, fractals mimic tectonics. The red line is a fault, and this guy in white that I'm circling is just like that Russia refold that we just saw. And there is a fault there, so everything wants to go in. So there's this mimicking of tectonics. Okay, so fractals and structures are consistent. You have a structure here, and I think it's a structure here in blue. If it's a fractal, it's still consistent, but you have this movement here, and sure enough, this structure or fractal in blue gets moved according to the structure movement. And interestingly enough, this is whether it's a structure or fractal. This is definitely a fractal here, and they are consistent because there's this headwinds going on here, that movement in that direction. Okay, the fractals and structures are consistent here. This is a SC structure in yellow with the energy going in the direction of the yellow arrow. And it looks like the back is breaking for this green fractal that is like a mini Rodinia. It is being pulled in the direction of the energy of the structure. Okay, this slide shows Greater Adria, which is a geologic mystery. Why does it look like it does? What's it doing there? Well, my model solves everything perfectly, okay? And there's consistency here. There's the crushed arm of the Africa refold in blue. There's Greater Adria outlined in red. There's a shearing. That's why the top hat of the whole Greater Adria got shoved off and pushed down there. Okay. Okay, this is a geologic mystery called Zealandia. It's a microcontinent. So they're wondering, why does it look like it does? Here it is, published article here. Why does it look like it does, and what's it doing there? Well, my model explains that absolutely perfectly. Absolutely perfectly. And been trying to get a hold of the authors for this, Zealandia, and for Greater Adria, another microcontinent. Haven't heard anything. Over the last couple of years, I've tried a few times, each and every author. Haven't heard a thing. Strange. Okay, again, another geologic mystery. Why are these gravity anomalies where they are shown here? Why are they there specifically and only there specifically as two distinct dots as such? My model explains that perfectly again. So here's those two dots, 1, 2. I explain in detail in the PowerPoint presentations, the 4 of them, or at least a couple of them, I explain that in detail. Okay, so there's this magnetic anomaly in Africa, right here where I'm circling, and my model solves, it at least gives tremendous insight as to why it's there and what could be going on. I talk about it in great detail in the PowerPoint presentations. Okay, so this is a fractal of early Earth, not too long after the Thea impact, and the locking mechanism has stabilized here, and it's not quite stabilized here. There's like a hole here. So that's where these critters, these little Rodinias, they're looking for a heat source. They're trying to get into that spot specifically. And right now, that spot is where there's an existing gravity anomaly around Antarctica on the South Pole. So that's the South Pole there. This is the North Pole here. Okay, these are fractals of high energy events. This is when Rodinia released the moon and started its journey towards the inner Earth. Wow, that sounds weird. That doesn't fit into your belief system. I realize that, but well, better think about it. Better check out and take this model seriously because it solves a lot of things and it works out beautifully in a lot of aspects. And it actually agrees with the current model. But anyway, there's 3 different ones here, all similar in a lot of ways. 3 fractals. Okay, these fractals of Rodinia are, they're stamped on top of everything, just overprinted on everything. And I think they're on the order of thousands of years old because you can see erosion has taken away some of these fractals. Okay, another example of erosion truncating a fractal. Okay, here's 2 fractals that could represent different phases, which you see often with these fractals, and they also share boundaries. So you can see there's some boundary sharing here with the 2 legs right there and right there. Okay, check it out. Interesting stuff. Okay, so these fractals often speak volumes, and they show different phases of geologic events and everything. That's what happens here. I found this beautiful fractal here, and this is published literature. They match very closely, and I could explain what the different phases mean based on my model. Okay, so these fractals that are like little Rodinias, they're found everywhere in the world, not just North America, and it's like they're the DNA of the land. Like I said, they're overprinted on everything, and they're not just from the old rock. They're in the younger rock, and they're just overprinted over everything. They're only lost to like erosion. These are fractals in South America. You can see the different sizes and different shapes. Check out the one in the yellow. There's a gigantic one in red. So these are fractals in Australia. Okay, these are fractals in Africa. Lots of them, check it out. There is a relationship between their character and these existing faults, which I get into in another presentation. More fractals in Africa. And again, there is a relationship with these existing faults here, which I get into in another presentation, as I said. These are fractals in China, which is within the Southeast Asia refold structure, and they demonstrate clockwise rotation and later counterclockwise rotation. Okay, this is really, really interesting stuff. This is part 3, and I discuss how fractals reveal faults, fault systems, and fault interrelationships. Okay, this is a gigantic fractal in North America. The thing was heading this way, and it got caught into the energy of the counterclockwise rotation, as you can see, leading from its nose here. And you can see a consistent SC structure here, which means there's a force coming this way, this whole wraparound thing due to the asteroid impact, which was in here. And then it moved like this, and it struck like that, and then it moved that way. Okay, these are all different kinds of fractals here, and there's a whole story going on here. There is a definite pattern, and I get into that in great detail on one of the presentations, one of the 4 PowerPoint presentations. Okay, these fractals, again, they follow patterns, and there's a fault in here, so they're all going to go try to get into that fault. It's like a source for heat and everything. So this is color coded. The yellow guy here becomes the yellow guy there, right? Goes right into the fault. Check out the one in red. He's going this way. There he is again. The one in blue starts rotating this way. He's working his way. Next phase, he probably goes there and probably follows the guy in yellow right down the fault. Okay, here's another fault that's in black, and you can see these guys are going right down the fault. Look at the guy in green. Guy in red is trying to get right down there too. Wow, check this one out. Look at all those dudes trying to get into that fault, which is in red. They're trying to get underneath there into the center of the Earth or whatever, that heat source. Okay, so we have a published geologic map here, and it shows faulting. I can verify the existence of those faults based on the character of these fractals, and I could also refine them. So that's the value of checking out, analyzing these fractals. Okay, those black lines are faults, which are the boundaries of refold structures. They're just shown on land and all that. So where I drew in the fractals on the land, you can see like an area that these guys are really attracted to right here in particular. And there's so many of them. Just take a good look. You'll be surprised how many there are. Okay, here's another area that's not too far from where I just showed on the previous slide. Check out the character of some of these. Look at this guy in red. You could actually see like muscle flexing and legs and all that. Really, really interesting stuff. Okay, so this took several weeks to do. These are lots and lots of fractals in North America. And what they show is this fault system. And it's there's a whole dynamic going on that I get into in the PowerPoint presentations. Okay, this also took several weeks. This is the northern part of North America. And you can see these fractals. There's so many of them, and they indicate that there's really a fault system here. And it's associated with all the rotation about the asteroid impact area in Hudson Bay here. So everything comes to a point right here. All these faults are like filtered into one point. And then there's a discrete pathway of movement here, discrete fault, right here where I'm highlighting. And it actually is associated, I believe, with this continental drift over here, where it pushed off, as I show in the pink arrow. Okay, so I'm constantly finding new fractals and everything. So most recently, I found a bunch of them in Florida. I haven't found any there until very recently. I found a whole bunch of them. So those are the next few slides. One day, maybe I'll do another film, an addendum. Okay, on this and the next few slides, it's these fractals are showing an attraction to this fault that's in western Florida. So it hasn't breached the surface yet. Nobody really thinks of faults in Florida, but I think that it's probably a deep ductile fault that will eventually reach the surface, and I think it's going to be associated with like a continental drift kind of thing. Okay, there's that same fault is there in red, and these guys tend to get bunched up as they're jamming up into each other, trying to get into the fault zone. Okay, there's that same fault over there that's in western Florida, and these guys are, based on their noses and all, they're attracted to the zone. And this guy's starting to go up into the zone as such. This guy's trying to get over there into the zone. A lot of times faults are zones. It's not a discrete line, but I show it as a line here. All right, there's that same zone. A lot of times these guys are either parallel or perpendicular. Here's a perpendicular to the fault, and here's a parallel. If they're small enough, I believe they tend to be more parallel because they get really manipulated by the energy. In fact, look at the leg here and look at the character of the fault here. And here's two more in northern Florida.